So this problem is asking us to determine the tension in cables C and B if we are given the tension in cable A. So this is pretty much our free body diagram. It's pretty simple, but I think a good plan of action would be to redraw the triangles that this creates. So this is going to be our triangle for tension A, and we have this here, and this angle here is 15 degrees. And we're going to want to break these up into x and y components. So this will be our x, this will be our y for when we're doing the sine and cosine of the tension A. And tension A is 50 pounds. That's what we know. And then we have tension B, which is like this. And we do not know tension B. And it creates this triangle with this angle here being 45 degrees. And this will be our x, this will be our y component. And then our tension C creates a triangle like this. Tension C, we don't know tension C. That's our triangle, and then this angle here is 65 degrees, with this being our x component, this being our y. So from here, we're going to want to write our equilibrium equations. So we have our net forces in the x direction. So we have our tension A, our x component of tension A, which is going to be negative 50 times cosine of 15, because that's where the x component is, cosine 15, plus tension B, and we're going to multiply that by cosine 45, plus tension C, and our x component of tension C is the cosine. So tension C times cosine of 65, and this is equal to 0. So we can't do anything to solve for these yet. We're going to write our net forces in the y direction. So we have our tension A, which is going to be 50 pounds, and this is positive. It's going to be in the upward directions, times sine of 15 to get the x component. And then tension B, it's positive, it's in the upward direction. Tension B times sine 45. And then tension C is in the downward direction, so that's going to be negative. So that's going to be minus tension C sine 65 equals 0. So we can rearrange our forces in the x direction to get tension B is equal to 50 times cosine of 15 minus tension C cosine 65 divided by cosine of 45. And that's just rearranging our terms in this equation up here. So we can go ahead and plug that into our net forces in the y direction. So when we do that, we're going to get, we're going to end up being, so it's equal to 0 times 50 sine of 15 plus tension B, so we're going to plug this big string in, this big value, 50 cosine 15 minus tension C cosine 65 divided by cosine 45, and then that's multiplied by our multiplier on tension B, which is sine 45. And then we have minus tension C times sine of 65. So when we do that, we can actually, so these will cancel, our cosine 45 and sine 45. Cosine of 45 and sine of 45 are the same, and cosine's on the bottom, sine will be on the top, so they'll just cancel like that. So once we have this and we do some rearranging, we get that tension C is equal to 50 sine 15 plus 50 cosine of 15 divided by cosine 65 plus sine of 65. And then from there we get tension C is equal to 46.1 pounds. And then when we plug our tension C back into this equation, we can solve for tension B. So we're plugging this back into this, and we get tension B is equal to 40.8 pounds. And that is our final answer, and that's what we solve for the tension forces for C and B in this cable.